Welcome. Speaker today is Michael Hawkins. He is from the natural resources. He is a natural resources biologist at the Iowa Department of Natural Resources, Fisheries. And today he's speaking about the common carp management and lake restoration.
Well, thanks. I mismatched my presentation. If anybody notices the title here, I was doing a little bit of research on some Latin terms. Of course, Carpe Diem is seize the day or pluck the day, and my play on words doesn't quite work. So I went and found the old German word for carp, which is K-A-R-P-E, which is the root for common carp. So the title of the presentation should be Carpe Carpe, if you mix Latin and German together. So what I'm going to talk about today is the kind of the melding of watershed management and in-lake management, or in-stream management if you were working on a stream. I think I think most people understand that there's a lot to manage in natural resources, and we've got to take a kind of a holistic approach. It's not only what happens out on that watershed. It's not only what happens in lake. It's a combination of those factors. And we really need to be looking at comprehensive management practices if we're going to have some impacts on resources. So this particular presentation is about some restoration work that's been ongoing at Lost Island Lake, and I'll give a status update on that project. And so we'll start the presentation where this project actually started, which was a question by a number of stakeholders in the Lost Island Lake watershed, folks that lived on the lake, and a few stopped into my office early on back in about 2007 and wanted to know, where are the bluegills in Lost Island Lake? We'd like to have some bluegills. Could you stock some bluegills in there? So we have some. And, Lost Island Lake's a 1,200-acre natural lake, and stocking bluegills is not something that's going to have any impact. We would stock bluegills into a new lake system, but if habitat and water quality is good, bluegill populations are going to take care of themselves. And so that's where the discussion led with these folks, was not about necessarily bluegills, but why bluegills weren't doing well in Lost Island Lake. And really, when we look across the state, and some work's been done at ISU looking at indicators of good water quality and water quality in lakes, bluegills kind of come up towards the top there. They're kind of those populations, and their health is kind of like the canary in the coal mine. If we don't see bluegills in an Iowa lake, there's a problem. Or if there's some issues with the bluegill population, there's usually a water quality or habitat type issue. So that led this discussion into the Lost Island Lake project, and working with this group at Lost Island and a number of other partners, and I'll list those later. But this was a big effort. Using that discussion, we set an objective to improve water quality and ecological health in Lost Island Lake. And so we were really looking at this kind of holistically and seeing if we couldn't get a response in the system. And so, breaking this down, of course, one component of looking at lake health is watershed and the health of that watershed. And so when we looked at the problems associated with Lost Island Lake, it's got a fairly small watershed, and I'll get into some of these figures in the next couple slides. But the watershed itself, about a 4-to-1 or so watershed to lake area ratio, doesn't have a big watershed, but it has a lot of marshes in it, a lot of wetland components to its watershed, and those wetlands were not in good shape, very turbid, devoid of a lot of aquatic plant life, just not healthy. And so one of our objectives here was to improve the health of these watershed structures, the wetlands that were in the watershed of Lost Island Lake. And of course, long term, trying to improve some land use practices in the watershed as well for nutrient and soil sediment delivery reductions. And then we got into this in-lake component. So the watershed and the in-lake components of lake management kind of work together. But we understood through some work previously that about 60% of our loading of phosphorus being the limiting nutrient for production, algae production in these systems, about 60% of the loading was coming from in-lake sources. So 40% watershed, 60% in-lake. That points to factors in lake, wind and wave action, sediment and resuspension, but also the action that common carp can have in the system. And so as part of our project, we wanted to look at the common carp population. And in doing so, we're going to use kind of the best science, the newest science coming out of a couple universities, University of Minnesota and South Dakota State in particular, looking at restricting critical spawning habitat, keeping adults out of critical spawning habitat, which happens to be these marshes that are in bad shape in the watershed. So putting some barrier systems in place and doing some renovations on those marshes. Some top-down type work with predators, so some things that our Fisheries Bureau already does pretty well in stocking predator species to try to get some top-down control on common carp and other problem species. And then when we kind of took care of all of that, we were looking at what I'll concentrate a lot on in this presentation on is this large-scale removal of common carp and kind of the effects that we saw in this project. So taking a look at the Lost Island Lake watershed, as you can see, that top portion there in black is the Lost Island Lake watershed, and then we have Behringer Slough, just to kind of give you an idea how water flows through this system. Comes down through a series of marshes and into Lost Island Lake, and then out through Behringer Slough. And so when we looked at this, we've got a lot of public land outlined in green there, a lot of permanent perennial cover on the ground in the watershed. Not a very big watershed to lake area ratio, like I had said. A situation that really kind of lends itself well to some nutrient management work. And so it's not a 30-to-1 or 50-to-1 watershed to lake area ratio where you might experience some difficulties in getting some control on nutrients coming from the watershed. Just to kind of give you a quick look at Lost Island Lake, it's not a really deep lake, but it does have fairly steep sides, and we're looking at wind and wave modeling and resuspension of sediments from wind and wave action. Probably not a lake basin that's shaped in a way that you would get a lot of resuspension from wind and wave action, and we probably don't see a lot of that. There is some, it's real windy days in northwest Iowa. You can get some sediment resuspension, but for the most part, it's deep enough. That point in the deep there in the middle is about 16 feet, so maximum depth of 16. Average depth in the main basin there of about 12 feet. These areas highlighted in green are kind of critical areas for the project. These are areas where we had identified where a lot of reproduction, carp reproduction was occurring. And not a lot stopping them from getting into those areas. As we get more into carp and carp biology, we're understanding that the importance of these types of habitats for carp reproduction. So to back up a little bit, I just want to talk about carp behavior a little bit. I'm used to talking with fisheries folks, so kind of an understanding of how carp can be detrimental to water quality. But they're doing a couple things out there. Carp are, by their feeding habits alone, are pulling material off the bottom of the lake. They're filtering it out a little bit and eating a whole bunch of different organic material out of that lake bottom. And they kind of blow it out their gills. If you've ever seen a video of a common carp eating or feeding, they're pulling a lot of material in through their mouth and they're kind of expelling it through their gills. And you get lots of carp doing this. If we get a population that's out of whack, the cycling from just the bottom disruption, nutrient cycling from bottom disruption can be enough, but they're also cycling nutrients through excrement, and we may be looking at situations with extremely high densities in some of these natural lake systems. And through a lot of experience with fish renovations, if anyone saw Ben Wallace's talk yesterday, after a fish renovation where we eliminate carp completely, it's often enough to flip a lake from a turbid water state over to a clear water aquatic plant dominated state. So these common carp can play a pretty integral role in water quality, especially in high densities like we see them in a lot of our natural lakes in Iowa. So controlling those populations is going to be important into the future on a lot of these systems. And in a situation like Black Hawk Lake that Ben talked about yesterday, there was a complete renovation done and eliminating carp and then trying to exclude them and keep them out. In systems like Lost Island Lake, where we're looking at maybe 1,200 acres of size, quite a bit of lake volume, plus these very large attached marsh systems, getting rid of carp completely is pretty unfeasible. And so what we're looking at here is trying to control their populations. And so by identifying those places where they're reproducing, those are the places that we can have some impact on the common carp population. And I'll get into removal as well, because that's a little bit of a misnomer, the commercial harvest of carp, and I'll get into that. So those marshes and rehabilitating those marshes, what we did was to do drawdowns of these systems, pull the water out, simulate a drought, and we do two things. We eliminate any adult carp and young carp that might be in those systems, but also these marshes need to go through these cycles, these drought cycles for germination purposes. And you get these really intense vegetative responses. So a lot of emergent cattail, bulrush, sedges, arrowhead, a number of aquatic plants that come back into these systems after they've been drawn down and allowed to go through a germination cycle in the spring. And so we did that on all of these marsh complexes that you see in the watershed. To do that, we had to put in water level control structures, systems that were able to, that made it capable, added the capability to be able to draw these water levels down. So in these locations, we did that. The existing infrastructure, if you look at it, had very little water level control structure, or water level control capability, and it also did not keep fish from moving. So fish could move right through these, right and up into these systems with pretty much ease. So they were able to do their spawning runs in the spring and get these large year classes off. So we replaced a lot of these systems, a large investment in the watershed to create these water level control structures that also have exclusion devices on them to keep carp from reinfesting these areas, or at least slow that the progress of those carp from reinfesting into these systems. And we spent approximately $1 million on infrastructure upgrades. Most of these structures had been 1930s era type structures that were in place, and so they indeed needed some updating. In one area, we actually installed an electric fish barrier to stop common carp from going up into the upstream portion of the watershed. So implemented quite a bit of new technology and engineering on carp management here on this project. When all of this was done, we then concentrated on the carp population itself and trying to reduce those numbers. And reducing numbers or harvesting alone isn't something that really works very well. And if we step back into the history of carp management in Iowa after their introduction in the late 1800s, from 1909 to 1930, after we figured out that this wasn't such a good idea to introduce common carp into Iowa, there was a commercial program that was initiated to try to reduce their numbers and control their numbers in many water bodies in the state, especially the natural lakes region in northwest Iowa. So that program ran for a number of years. There was a commercial opportunity and a commercial market for common carp, and they were sold. About in the 1930s is about the time that beef and hogs and chickens and those types of protein sources became a lot more popular and readily available in the United States. And so the commercial program died in the 1930s because of a lack of market. From 1930 to 1972, the state of Iowa picked up the baton and started removing common carp in massive numbers, again with this objective of trying to drive their populations down. During this time, there was a couple published papers in Iowa on the effects of these reduction efforts, and a couple success stories that may have taken place through time back in the 1940s and 50s. But long term, they really did not see any benefits. These common carp can reproduce. They can reproduce very quickly and refill the void. So you can harvest, they can sustain pretty intensive harvest and without affecting their population overall. So in 1972, we gave that program up in Iowa, and we went to our commercial program where there was a market developing for carp and buffalo, largemouth buffalo, the two main species of commercial harvest on inland lakes. And so from 1972 to the present, we allow this commercial program to exist, and our objective has changed. We're simply allowing these commercial anglers to utilize an unused resource. And I think a lot of people in the public, especially living on these lakes, see this as a program still to try to reduce numbers, and when that's not actually our overall objective. So in this project, we're kind of going back to this. We're kind of going back to the old commercial days where we're trying to reduce numbers of carp in the system. And so why do we think we're going to be successful? Well, we feel we've got a much better understanding today of the system, and specifically some of the life history and science of the common carp life cycle. And again, some of that key research coming out of the University of Minnesota on the Sorensen lab, and also at South Dakota State University, and now Iowa State University as well is going to be picking up some work on common carp and common carp populations and trying to understand these critters a little better. Recruitment control, I've talked about that. We're blocking these fish from getting into these spawning areas, these critical spawning areas. For removal, we're setting some very specific density objectives, again, based on the current science. We're working on actually paying the commercial angler. So today, on a commercial contract, the commercial angler actually bids on the project, and they end up paying the state a small fee to fish these lakes. Kind of flipping this around in this particular project where we're paying the commercial angler, and we're setting out some subsidies for them, some economic benefits to keep after the project. And that's important because, as you can imagine, as a commercial operation, when your catch starts to drop off in a lake, you pick up the nets and you head to the next lake where your catch is going to be better. You're all about the profit there. About the time they leave is about the time we want the commercial angler to stay in place and continue to harvest carp. And so the subsidy is going to be important here as we get into the specifics of the project. And we have all of our partners and stakeholders all kind of understanding this process, understanding why we're doing the things that we're doing. And everybody's kind of working towards that common goal. And that was done through a lot of education and support. County Conservation Board was really important in that, and lots of public meetings and understanding the lake. So the subsidy I'll go through because I wanted to touch on this. This is pretty new stuff. The state of Wisconsin is working on some subsidies, so is South Dakota and Minnesota. But this one has been held kind of as one of those great successes in common carp reductions, so we'll kind of highlight it here. The most fish that the commercial angler, the most carp that the commercial angler had ever removed under one contract cycle at Lost Island Lake was 200,000 pounds. So that was the best that they had ever done. So we knew they could do that on their own. And we knew we had a pretty high density population that I'll get into here in a second. But we started with this 200,000 pounds. This is on your own. This is the minimum. If you get this contract, you have to do these minimums. So they knew that going in this contract. Once they hit that 200,000 pound mark, we started to add some incentive. And we actually almost doubled the price of what they were getting for the carp. So it just became lucrative to stick around a little bit and continue to fish on this lake. And they do this with these either under ice or open water, very large seines, up to 2 miles long, that they do. They encircle areas and pull these fish in and sort them and then harvest off these carp and largemouth buffalo. So at this point, we've got them there for the 15 cent per pound subsidy. If they could reach 300,000 pounds, we had an $8,000 cash bonus. If they could reach our target of 400,000 pounds, they got a $12,000 cash bonus. So you've put all these numbers together, there's about $50,000 on the table here for reaching this 400,000 pound goal. The commercial angler actually thought, you know, we're going to help you out here. We really don't care about this subsidy. You know, we're going to fish until we feel like we've got enough fish, and then we'll take off for the next place. So we're really counting on the subsidy to work. Well, what were the results? 431,000 pounds of carp. So they did stick around to get all of the money off the table that we had there for this subsidy, and pulled 431,000 pounds of carp out of the lake. I'll get into what these numbers really mean from a lake standpoint, but and additionally, they took 353,000 pounds of buffalo during this contract. And we've since had some other small contracts to kind of keep ahead of this carp population. And so I'll just kind of list some of these numbers. But all in all, we've taken a lot of fish out of the system, out of this 1,200 acre system. Just to compare some of the commercial harvests through time, just to give you an idea of how this stacks up against other years. The yellow is common carp, the red is buffalo, largemouth buffalo. You can see that in 1999 was that year they almost hit 200,000 pounds of removal. That's kind of what gave us this goal, this initial goal of 200,000 pounds. And you can see through the contract cycle there, that's where they removed these large numbers of fish. So how this kind of stacks up as far as the removal efforts through time and the commercial effort there. Just some numbers here. This starts to get into some density stuff. So 743 pounds per acre of common carp and buffalo were taken off of Lost Island Lake. We tend to see standing stocks of all fish at about that level. So we're pretty sure that most of the fish biomass was tied up in these two species on Lost Island Lake. And so it's been kind of interesting to see what happens after you remove that. Since that time, the commercial harvest has fallen, and that's where we it's not because they haven't been trying, it's because we don't have any fish out there. So we'll get into those numbers next. But all in all, since the beginning of the project, from when the guys came in to talk about bluegills, we've taken about 1.3 million pounds. Now these numbers for pounds per acre are a little deceiving because fish grow. When we're talking about 1,100 pounds per acre removal, that's not an instantaneous value. That's a value, a cumulative value over the years of those harvest events. Just a few pictures. If you've never seen commercial carp harvest, commercial harvest in general of fish, pretty impressive. Some big equipment is used. This is a 150,000 pound haul that was done underneath of the ice. So you're just seeing the top of this giant balloon of seine underneath the ice that they're pulling up out of this take hole here and tightening this up and sorting out fish. Highly mechanized. These guys don't mess around. They've got semi after semi after semi coming in to take these fish. A lot of the buffalo head out on the live market, so they're hauled away about 18,000 pounds at a time on live trucks with liquid oxygen. The carp are actually shipped, most of the carp in the Midwest are shipped to Spirit Lake, Iowa, where they're processed. Most of those carp end up as gefilte fish in the Orthodox Jewish markets across the United States and across the world, actually. That processor up there kind of has the corner in the market on gefilte fish. So it goes into a ground meat product for human consumption. Just a few more pictures. The sorting process. And I want to go through what that's meant for the lake. So, when we set targets, we don't know where we're beginning. And so you've got to apply the science first. And part of that science is understanding how many fish do we have. And that's done through some pretty intensive methods of mark and recapture. So you're taking thousands of carp, sampling those out, clipping a fin or giving them some kind of a mark, putting them back into the population, then resampling through time. And through some modeling, we're able to then estimate the population of fish and estimate some biomass figures. So on the left, you see the number of carp in the lake. On the right is their biomass, or the number of pounds per acre of fish. You can see when we did the event, the population dropped pretty dramatically. And our goal in this project was to drive that population below 100 pounds per acre. That's where the literature told us that we would start to see some water quality effects. And what's nice about what's happened there, one of the great things that's happened there, is we haven't seen this population rebound. So our control mechanisms are actually allowing us to keep these fish in this state. This is just showing the size structure of the population increasing through time. So from 2008 pre-project, or right at the beginning of the project, through 2015, where we've got a lot of large individuals. And what you'll notice is that we aren't filling the population in with small individuals. So that recruitment control portion is working. Mean weight, these carp are getting huge. Well, you take the cap off the population and they're able to grow. And grow they do. So the remaining individuals have gotten very, very large. Along the way, I won't get into the details, but these are all the predators we've stocked into the system. So we're putting a lot of top-down control in as well. So just to get into a few results, these are been of our water quality trends through time. This is through the ambient lake monitoring program. And most dramatically, you can see this drop in turbidity, or the amount of material in the water that's being stirred up. So we've seen this pretty rapid drop, big drop in turbidity. We've also seen an impact of secchi. Water clarity has gotten better. Aquatic plant response, from 1996 to 2001, the surveys never found plants in Lost Island Lake, submerged aquatic plants. In 2012, after the project, about 28 out of the 30 transects, we've been finding vegetation. That's dropped off a little bit here in the recent years, but it still remains, there's still plants in the system. Some final thoughts. We had some great local support and enthusiasm for this project. Anytime you're taking 1.3 million pounds of fish out of a lake that people don't want there, you're going to have some enthusiasm about that. But our subsidy was effective. We've been able to control recruitment of carp so far. We've had some positive aquatic plant and water quality response to this project. And we're still working on kind of this importance of buffalo, and we're going to maybe look at some future research projects to look at largemouth buffalo and their role in water quality as well. They're a native species, but in high densities they may be able to cause some issues similar to what carp do. So I'll finish the presentation kind of getting back to this question that we had at the beginning of the presentation that these guys from Lost Island Lake asked about, is why don't we have any bluegills? Well, we've been indexing populations down there. We do a lot of fisheries sampling in Iowa, and we've been indexing young of the year, so these young bluegill populations, and we're looking at all young of the year fish from a reproduction standpoint. And you see here is the number of age 0 bluegills that we get per seine haul that we do along the shores. And we've been doing this since the mid-1970s. Well, if you look at the last few years, we've seen some pretty positive trends in bluegills, and we're starting to see some of the bluegill population come back there. So, in the end, that's these biological indicators are also giving us some positive trend information, and we're also getting some anecdotal stories from Lost Island Lake, and I won't get into that, but that's a quote from a longtime visitor to the lake and a lake homeowner. So, some pretty neat stuff. And I'll finish with just some acknowledgments. All the groups and organizations, agencies that worked on this project. It was a large task, a lot of work, and we were going to continue to manage into the future. So if we see a response in carp, we're going to know that because we're now monitoring, and we'll hit them again and try to drive that population down. So.
Have you been doing any fish stocking after the major carp biomass removal?
Yeah, so that slide that I showed back there, our normal fish stocking of walleyes, we've enhanced that with some additional fingerling walleyes, some large northern pike that we've been putting into the system, largemouth bass, which is not typically stocked into an existing fishery, but we've been putting in 5-inch largemouth bass every year, and we're seeing some response to that. So yeah, we're trying to do some top-level control from a predator standpoint.
What vegetation reemerged in the lake? You had the lake that had no vegetation, and then what infill, what type of species?
We see a lot of sago pondweed. Coontail is another species. Some larger leaf pondweeds we're starting to see. Pretty good diversity, and it's amazing. You know, that stuff's there. It's the seed beds are there. They just need the conditions to grow. They need sunlight penetration to the bottom, and that's what they're getting now.
Your improvements on the limitations of the carp affected your other fish species improvement? Are there any of the natives that are likely to be adversely affected by limited access to environments?
It's actually a question we get quite a bit. Northern pike would be adversely affected, would be a species that could be affected by that. Some of the barrier systems that we have in place probably aren't going to affect some of the smaller fish, smaller bodied fish, if they're going to go in there and use those for spawning. But northern pike would be affected because that's their spawning habitat. And we're augmenting this with some northern pike stocking to kind of take that place. So yeah, you could. The cost is worth the benefit. Sir?
Yeah, I'm just curious as to how the under ice seining operation actually functions.
Yeah. Yeah, and that's a good question too. It's pretty fascinating to watch them. They'll draw, and they run this large seine out. It's very similar to the shoreline type seining that they would do, but they run the seine out in a big semicircle and then pull it to a central hole. They use a variety of tools for doing that. They used to use really long boards, drill a series of holes, and run a feeder line by pushing boards underneath there. Today they use a small submarine with large lights that face up, and they can walk above and see the lights underneath the ice and guide the little homemade sub, around with a little feeder line, and they can go from hole to hole and hole, and then feed the seine out and then back to the hole, or the takeout hole. So, pretty fascinating. Another good question. They're very expensive, and we've been pretty frustrated with this particular electric barrier. They work when there's always positive flow. So when there's flow coming out of the marsh, fish will come up to the electric barrier, and they physically can't pass the barrier. I mean, the electricity stops their swimming ability, and the flow ends up pushing them back into the lake. So if the barrier's up and running, it's working when the marsh is flowing out. If we get flows that start to drop down, and then we get a heavy north wind that blows or piles water onto one side of the lake, you can actually get a reverse current. Well, fish can get stunned. It doesn't kill the fish. They get stunned. The current will float them through, and they're onto the other side. So it's actually a two-stage barrier. So we have a physical barrier that drops during low flow, and then when flows get high, we can't have the physical barrier in place because of all the debris that comes out of the watershed, mostly cattail material, aquatic plant material. So we lift the barriers and allow that to come through. Somebody's got to be watching that. We do have a flow meter in the culvert. We're working on making that work a little better. It's kind of an automated process when the barrier will come on. But they're a pain. They're expensive, and you have to manage them. So when you always have positive flow, they just kind of do their thing, and you don't have to worry about them. But this kind of reversal of flow is a hard thing.
Is it the same challenge they have with trying to keep the net tarp out of Lake Michigan and Chicago there with the barrier?
Yeah, there's some additional challenges there. That's a large area that they're trying to electrify. So trying to get the electrical field strong enough in all those areas, and then running a steel barge through that really bends the electrical field, and so they've got some problems with that. We have one other electric barrier in Iowa up at the Iowa Great Lakes, and that's an Asian carp barrier. Much larger, much wider, 160 feet wide. Always has positive flow on it, so it's part of a dam structure. And very inexpensive to operate. Very expensive to put in, but it doesn't take a lot of electricity to actually run the system. So.
Thank you very much.
Yep.